Hello, my name is Ezema, and today I'll be presenting a study on social interaction and social preference in DAT++ and DAT plus minus mice. We performed this study during spring of 2021, and we were interested in the role of social play and how it influences social motivation. So we looked at social play and preference in adolescent mice, which adolescents and children are between 6 to 8 years of age. We recorded USV or ultrasonic vocalization in mice as well as the behaviors for our methods. USVs are released during communication in mice, almost like syllables in humans. The difference between our two methods was that in social play, mice were able to physically interact with one another, performing behaviors such as dorsal pinning, which some see as roughhousing in kids, or following, which some see as tag. There were also behaviors such as nose to nose and nose to anus, which we observe in dogs during sniffing. And for the non-social behaviors, there was rearing and self-grooming, which they see as anxiety-based behaviors or repetitive behaviors. So these behaviors were noticed in the preference test, in the play test rather, not so much in the preference test due to confinement of the novel mice. We also noticed that for the play test, differences with genotype was based off the USVs rather than their behavior. USVs emitted in playtest shows that there is a significant difference in calls emitted by both male and female mice, with males emitting less calls than female mice, and with male and female heterozygous mice, or DAT plus minus mice, they have released more extending calls than the wild type mice or plus plus mice. We haven't really related the calls to behaviors, but we suspect that the differences in calls may be reflective of their genotype and the motivation associated with elevated dopamine function. The results in social preference test fits our hypothesis, stating that reduced dopamine transporter function increases social motivation and preference. We also observed that there is similar results between sex and genotype during social preference tests, where isolate mouse is given a choice to interact with novel mouse or object in phase 2 of the preference test. The female wild-type mice and the male het mice exhibited no preference for the social stimulus or the object during the phase 2 of the test, whereas the female het mice spent more time in the compartment with the other mouse. For phase 3 of the social preference test, where the mice were given a choice between the familiar mouse or a stranger mouse, all subjects showed the preference for the stranger mouse rather than the familiar mouse. To better understand the neural activity, we actually have to look at social interaction under different circumstances because that's where USV is emitted the most. And because of timing, we weren't able to get through all of the results, but stratal samples, which is collected from the brain of the mice, and measurements of CFOS activity, which helps us to understand neural activity in the brain, will help us understand areas of the brain that's actually affected by social play at an early stage in life. With that said, I'd like to thank the Office of Undergraduate Research for funding this study, and I'd like to thank my mentor, Dr. Frank Hall, for allowing me to work alongside him on this project. Thank you.